it would be very difficult to actually smell it. However, since the suffocating, cold atmosphere would take you first. Uranus smells like rotten eggs, scientists have found. And that's not even the worst of it. The planet's cloud tops are partly made up of hydrogen sulfide, the same chemical that gives rotten eggs on Earth their disgusting odor. As such, anyone who actually managed to arrive there would smell the pungent aroma. If an unfortunate human were ever to descend through Uranus's clouds, they would be met with very unpleasant and odoriferous conditions, said Patrick Irwin from the University of Oxford, one of the team of scientists who explored the planet's chemical makeup. But anyone doing so would have much bigger problems than the stench. Suffocation and exposure in the negative 200 degrees Celsius atmosphere made of mostly hydrogen, helium, and methane would take its toll long before the smell, said Irwin. The composition of Uranus's clouds has been a long and difficult mystery for scientists, despite the fact that we have learned great detail about the other parts of our neighbor. Now the new research unlocks that stubborn mystery, revealing some of the makeup of the clouds that float over the planet's surface. They did so using sensitive spectroscopic observations taken from the Gemini North telescope. By dissecting the infrared light coming back from Uranus, scientists were able to understand how its clouds were formed. Scientists have long argued over whether the planet's clouds were made up of hydrogen sulfide or ammonia, but there has been no clear evidence or proof either way. Now, thanks to improved hydrogen sulfide absorption line data and the wonderful Gemini spectra, we have the fingerprint which caught the culprit, said Irwin. The discovery means that Uranus is distinct from Neptune and Jupiter. Those other planets in our solar system show no hydrogen sulfide on their surface, instead showing ammonia floating above the clouds. That difference was probably determined at the very beginning of our solar system and was determined by the way they formed. During our solar system's formation, the balance between nitrogen and sulfur, and hence ammonia and Uranus's newly detected hydrogen sulfide, was determined by the temperature and location of planets' formation, explained Lee Fletcher, a member of the research team from the University of Leicester's Department of Physics and Astronomy. Thanks for watching this video. Do not forget to like and subscribe this channel. We will present facts, mysteries and myths that are useful to you.